Good afternoon, all of you. Welcome back to the practicals on system security. So during our previous session, we implemented a CISA cipher encryption technique, and also we demonstrated. We wrote the program for the encryption part. Also, I gave the decryption part to you. Also, I've shared the link through the Zoom as well as the link was shared in the Moodle account in order to upload the write-ups for the first experiment. I received only few responses from those who have attended the practicals, but few of the students or most of the students, their submission for the first experiment once write-up is pending. Right, by end of the day, they need to complete the experiment once, write-ups to be submitted to the given link which is shared in the Moodle account. So during our last practicals, we discussed about CISA cipher encryption technique through the programming with the help of the code blocks as well as through the C language. We implemented how the CISA cipher encryption was implemented, right? With the continuation of that practical in today's practical, right? So this I could say that. So the remaining the two practicals which I will be performing today, you will be performing today, are become the part of the first experiment, right? 1A, 1B, and then 1C, right? So next we'll be discussing about or we'll be performing about the affine cipher. What is meant by an affine cipher for your refreshment, right? And I just wanted to know what is meant by an affine cipher. I explained all the theoretical concepts during our lecture explanations. We solved the problem based on the affine ciphers. We solved 2-3 numericals based on the affine cipher. So I just wanted to understand how we understood the concept of affine cipher. What is meant by an affine cipher? Anybody? Your active interaction is expecting. Yes, it is one type of monoalphabetic substitutions. It is correct, but actual logic behind the affine cipher. So there are some formulas, some standard techniques, a standard method through which the encryption as well as decryption has to be carried out. Sabina, Naval Chavan, what is affine cipher? If you don't understand the logic, it will be very difficult to implement the practically through programming. Very good. Josefa, your answer is correct, right? AX plus B or alpha x plus beta, which is mod M. Okay, correct. So for quick refreshment, I'll just share the screen. I'll explain the concept theoretically for a few minutes and then we'll start with the program. Those who are directly attending the practical, for them, they will get no brief idea about what is the affine cipher. And then I'll explain with the program through that you will understand the concept clearly. Now, this is what the same example which I have explained during our lecture, right? When we talk about an affine cipher again, which is a kind of a substitution technique. Give me a second, I'll take some highlights. Okay. So when you talk about an affine cipher, normally the CISA cipher encryption algorithm which works based on that, whatever the thing which we write. Say for example, this say for example, cipher text equal to plain text plus 3, right? So this is what the logic behind the CISA cipher encryption technique. The problem with the Caesar cipher encryption technique, so this is a commonly known algorithm, right? If the user is trying 2 power 26 combinations, right? So probably they will get a chance. They will get a chance to crack what the message has been conveyed, right? So to avoid that, so in order to increase certain complexity in the encryption part, right? The normal encryption technique, right? Whatever the information they are going to send, right? The plain text, they are going to use some mathematical formula or mathematical function with the help of that. So they are going to do the multiplication with the constant value. So that is, say for example, if I am taking ax is my plain text, the plain text has to be multiplied with the constant value. So for example, if I am taking my a value is equal to 5, so whatever the number which I am maintaining, right? So this the corresponding mapping values to the English alphabets, right? So the Caesar cipher text technique, sorry, this affine cipher text techniques, right, which will be implemented using this a multiplied by ax plus b, right? So we can consider it as AR, BR, alpha, beta. All those are the variables. We can use any variable. There is no problem with that. You can follow your own notations, right? But so here you need to select such a way that, right, this beta and then alpha value. So these two values should be relatively prime. What is meant by this relatively prime? The two values are relatively primes. That means that any number which you are selecting, right, the GCD between those two numbers. Give me a second. GCD between those two numbers, right, should be 1. Otherwise, there should not be any common factors between these two numbers except 1. So by the way, I am going to select the values 5, right? So for example, my plain text value which I wanted to transfer is HOW, right? HOW, right? Now, so first of all, we need to do the decimal number mapping for this alphabets, right? If suppose if I map A to 0 and B to 1, C to 2, and then D to 3, right? By the way, so this Z will be mapped to 25. I'm going to take the numerical mapping for the corresponding alphabets HOW, right? So for H it is 7, for O it is 14, and for W it is 22, right? So now I wanted to do the encryption character by character. So first I'll take the first character, which is H. So H is corresponding the numerical value, which is 7, right? I need to multiply this value, the input value X, I mean H's number value into the constant which I've selected, A value, which is 5. So 5 into 7 plus, this is what my beta value which I'm selecting, which is as a 8. So here my A value is equal to 8 and my B value is equal to, sorry, A value 5 and my B value is 8. If I substitute these values into the formula, which is Ax plus B, my A value is equal to 5, followed by this Ax. For this step, I am taking my H is the input, which is 7. So 5 into 7 plus 8 and followed by mod 26. Why we need to use mod 26? Why we need to use the mod 26? What will happen if you are not using mod 26? Anyone? Because we have only 26 alphabet letters. Correct. The correct answers, right, Anushka? Thank you. Right. The thing is that we have only 26 alphabets which are started from 0 to 25. If we are not now shrinking out the output values within the range, right? So we will not get the alphabets, right? So for that we are using the modulus with the 26 operations, right? So if you are Dividing this value, if you are substituting these values, so we will get 35, sorry, 5 sevens are 35 plus 8, which is 43. Now, when you apply 43 mod 26, you will get 17. Now, this is what the ciphertext numerical value. If you are mapping this numerical value to the alphabet, so I'll get R. Very similarly, if I do the encryption for the second character, which is O, O's corresponding numerical mapping value is equal to 14. So 5 into 14 plus 8, right? What I'll get? 5 14s are 70, correct? 70 plus 8, which is 78. 78 mod 26, right? Which I'll get 0, correct? So zeros corresponding numerical mapping, sorry, the alphabet mapping value is A. So my ciphertext value for the first character is R and for the second character is A. If you repeat these steps for the third character, 5 into 22 plus 8, so here you will get 14. So 14 corresponding alphabet value is equal to O. So my ciphertext value is equal to RAO for this plain text HOW using affine cipher when my A value is equal to 5 and my B value is equal to 18. Is it clear? I hope this is clear for all of you. If any difficulties to understand this logic, so you can write in the chat box or you can unmute and you can say that. Okay. So by the way, you can repeat all these process as many times you want as per the character you have. Right? I'll just clear all the annotations. So this is again the detailed explanation for individual characters. Again, encryption R A W, sorry, R A O, which this is what the ciphertext which we receive. When it comes for the decryption part, right? So decryption is little different with the encryption part. So here we have added the values, right? But whatever the alpha value which is selected, and we are going to select the inverse of that as alpha value, which is 26 minus alpha value. So for encryption, if I have selected my 5, and for decryption, I have to use 26 minus my A value, which is 21, right? And followed by this, what are the ciphertext value which we add, where we added the value, right? Now here we are going to subtract 8 from the ciphertext what we receive, right? If you are applying all this value, any queries? Okay, so when you talk about this, the ciphertext value which we received, RAO, right? So we are here also in decryption also we are going to process a character by character, right? So this is what the inverse of 5, right? So 26 minus 5, which is 21, followed by that the R's corresponding numerical value, which is 17, and this is my B value. So my A value is equal to 5 and my B value is equal to 18. If I subtract this value, right? So 21 into 9. If I multiply all this value, I'll get 918, right? And mod 189 mod 26. What value I'll get? Are you getting the result 7? You can check parallelly. 189 mod 26. Anyone can acknowledge. Is it correct?
Yes, 7.
Okay. So 189 mod 26, you will get the result is equal to 7. So this is what the plain text which we receive. The corresponding numerical value which has to be mapped to the alphabets, right? When we take this 7's corresponding alphabet value is equal to H. Very similarly, when you proceed further, you will get the different values, different ciphertext, right? So H O W, right? You can just work parallelly, and you will get the result, which is, if you are applying this formula, so whatever the value which is we are using, right? So 21 into and y minus 8 mod 26. So you will get O and then W for the next ciphertext what you receive. I hope the concept behind the affine cipher is clear for all of you. If you are clear with this, then we'll proceed with the explanation of the coding part, and then I'll demonstrate how the coding works parallelly. You can also execute the programs. Okay, so I'm getting the positive acknowledgement from your end. So I'll move to the coding part. You all might be familiar with that, how to install as well as how to create a project using the code blocks, and how to compile and then how to execute the programs whatever you written on the code block. If you have any difficulties, how to install as well as how to create a new project, and then how to write the program, how to compile, and then how to execute. And if you have any queries regarding the same, you can write in the chat box immediately. So I will clarify that, then we'll proceed with the explanation part. If you are clear with that basic things, then I'll directly jump into the coding explanation part. In the last practical, I just demonstrated how to install the code blocks, and then how to do the setups, and then how to create a new project, how to write the program, where to save, and then how to execute, how to build, and then how to execute the programs. All those concepts which are explained clearly, right? If you required, and the links are available in the Moodle as well as shared in the PDF file, which is through your official group. So you can refer those links, and then you will get more clarification. Still, if you have any doubt regarding the same, you can approach me. I'll be happy to explain you again. Right? So now, so this is the first part are the declaring the header files, right? Standard IO on the string.h, right? So, and the C type. So why we are using the C type dot header? So here we are using some conversion operations, right? Where we wanted to convert our the lowercase character into the uppercase character for uniformity, right? For that we are using the C type.h as well as standard library, right? Where we will be using a list of library functions which are related to the C programs. And apart from that, the standard library to which, right, I wanted to use some member function which is you will be using in a C++ Java language. For that, I'm using this stdlib.h, right? Through that, I can declare a member function here, and the member function again I can write a specific code in order to perform a certain operation, right? Is it clear? Right? So the first line is that our main function. So here I am declaring the few variable which I am going to use in the further programming part. I, J, K, GCD, right? So here I am going to use a variable GCD, right? GCD in order to check why we need to use for GCD, because whatever the value which you are selecting, right? I mean alpha and beta, right? And GCD between those two values, right? Again, so that should be the one, and then alpha value, beta value, and then so the temporary variables to store the num string, as well as a temporary variable to store the cipher text in the array data type, integer array data type, and followed by the characters in order to get the plain text as well as cipher text, followed by the printf statement. What is the purpose of the printf statement? Whatever the things, whatever the content which you are writing in the printf statement inside the double quote, all those information which are going to be printed or which are going to be displayed on the screen, and followed by that whatever the thing which you are going to get, right? So this again a gets function, whatever the strings which you are getting, whatever the things which you are going to type, and so with the help of the get function the input will be fetched here, right? Again, so here this for loop I am going to use as many characters, as many input which I am giving, right? So this the process, whatever the thing which I am going to write here, everything will be continued till the string length which is equal, right? For every if the I value is increased automatically, every after a character the I value will be increased, and whatever the value which is present in the specific location, that is going to be extracted, right? If the first thing is that I am going to check if the input should not be a null value or empty. Suppose if my plain text character consists of empty space or space, right? So that it needs to check if it is not an empty location or empty memory space, right? In that cases, whatever the input which is present in the I array, right? So that are going to be converted into uppercase, right? So what is meant by these two upper function which will perform here is that which will convert all the character which I am writing in small letters, that is going to be converted into the uppercase letter. So this is to upper is the function which is inbuilt function available in C language, almost in all of the languages, right? So that will convert whatever the input which is passes to the function, that will convert and then store in a place of J. So for every character the J value will be increased, and that will be stored in the corresponding the J position. For that we are using J plus plus, right? Otherwise, if the characters are already in capital letters, again, so this will be simply it will ignore and then it will move to the next letter, right? If it is a capital letter or if it is a blank space, simply it will move to the next position. Is it clear? Till this part, the declaration of the header files, and then declaration of the variables, and then getting the input from the users, right? And how this the converting this lower characters into the upper characters, right? Whenever it reaches the J string which is equal to end of string, right? So this is where, so this is a data type, right, which will be used to represent end of the data or end of the string, right? After that, right, whatever the strings which we entered, whatever the strings which are received using this get string function, so that are going to be printed using this printf command, enter the string, right? So here how the results will be visible, how the results are going to be displayed here, whether it is in the small letter or capital letters. Anyone? String. When you are printing this, enter a string is and percentage s, this is for string, right? And then str, how the output will look like. Will it be in the small letters or capital letters? Yes, Anushka, you are good. Your answer is correct, right? The output which are going to be displayed in the form of capital letters, right? So this part is done, right? I'll, if you want, I can explain, I can show it, right? I think this program is already running. I just checked it. So I need to stop it. Okay, now I can execute it. You can just click build and run. Okay. So now I'm going to demonstrate only the part which I explained. Say, for example, I'm just typing a string SAMPATH. I hope the screen is visible.
Yes, sir.
Okay, thank you. I'll just magnify the screen. Now is it a little enlarged? So this is what the input which no I am going to enter, right? If I enter this, right? So the entered string is right. So which is converted into the small letter to the uppercase letter. Right? So I hope till this part you are clear with it, right? So we'll move to the further coding part explanation. Right. Next is that I need to get the input values for both the alpha and beta values, right? So for that again, so this is very simple statement, right? Printf enter the alpha value, right? If you want, you can get both the alpha value as well as beta value in a single stretch, right? Otherwise, you can take it separately, right? So here I'm going to get the alpha value using the printf as well as scanf statement. I'm going to compare whether the alpha value which are within the range. If you want, you can add this part. Otherwise, you can skip, right? Manually, you can check that whether you are entering the correct alpha numbers, right? So this should be maybe greater than 0, right? You need to make sure that the alpha value should be greater than 0 and less than 25 or equal to 25, or you can assume it is less than 26. Here I am not using any equal symbol. For that I am just considering the lowermost as well as uppermost value. So here my range will be 1 to 25 only. I hope this is clear. So the alpha should lie between 1 and 25. Otherwise, right, you can just exit from this loop, right? And then I'm going to check this the value GCD, whatever the GCD which we are going to calculate, right? So here I hope here I have just declared the member function, right, which is calculating of GCD, right? So here for that I just added a separate line what the GCD function which does, right? So here this is what the explanation part, the coding part of GCD, right? Again, I'm going to get two values, right? Integer x value and then whatever the alpha value which I'm going to get, so that is going to be stored in temp one and then temp two, right? Now, how will find that whether the given number is, the GCD between the two number is 1. So we need to check that other than the 1, right? It should not be, there should not be any other common factor. First thing is that make sure that this temp2 should not be 0. And then if it is not 0, right, whatever the value which we are getting, and that we are going to store it in the x. Let's assume it is 26, right? And followed by that temp1 mod temp2, right? Here temp1, whatever the value which we got from the alpha value. Say for example, if I'm getting 5, my alpha value is equal to 5, and my temp2 value which is 26. Here it is default value. So 5 alpha or 5 mod 26, I'll get 5. right? So that is going to be stored in the temp value again, which is whatever the remainder value which I am going to get. So that is going to be stored in the temp, right? And followed by that, I'm going to check whatever the value which I'm going to get, right? So that is going to be written, right? So here, so whatever the value which we are going to get, right, that should not be greater than or 1. There should be only one common factor, which is 1. Is it clear? Any further explanation required? So this is an additional part. If you want, you can include this finding the GCD part. Otherwise, you can skip this part, right? If you feel little complex, you can directly select the number which manually you can calculate, as well as you can select the numbers, right? Where the both the numbers GCD is 2. Sorry, GCD is 1. Okay. So once if you are clear with this, then here we will get it, right? And then so here we are going to check that whatever the value which you are getting, where we stored the GCD value, right? GCD, here we are going to get the GCD right through the function, which is equal to, this is what the member function which I explained so far, right? Once again, I'll just take the annotation. What happened to my annotation part? Give me a second. Not getting the annotation rules. Okay, so we'll proceed as it is. I'll just, here I'm getting this spotlight. Right, I was explaining about this part, right? So we need to make sure that, right, GCD, if GCD is not equal to 1, right? So here we need to, so here this will exit, right? So it needs to, you need to select the two numbers, right, where the GCD between those two values should be 1. Very similarly, here also you are going to select the beta value, right? Again, the beta value, again they are going to check, they are going to whether it is no from, that should be, that should not be less than 1, or that should not be greater than 25, right? If it is in that range, again, so it can exit from the loop, right? By the way, you can select the alpha value and then beta value, which should be 1 to 25. What will happen if you are selecting my value is equal to 0? I'll get the same value. If I select 26, also I'll get the same value. So there will not be any encryption as well as decryption part. I hope this is clear. So far, whatever the thing which we explained, which are related to that, this part here, I just, if I am entering my alpha value, so here I need to include enter the alpha value and must be between 1 and 25, both included. So for example, I'll take the same number which I explained through the numerical part, theoretical part, right? And then my second value which I am going to select, again that should be in between 1 to 25, both included, right? After that, what it's supposed to do is this program part. So we defined all the GCD values and then we defined the alphabet values, we received the characters and we decided we received the beta values. Now what we are going to do is that, right? So here, this part, whatever the part which I am going to explain, so this part which are related to map my the capital A which are I am going to map to the 0. For that, for all the character which present in the string input which I received, I is equal to 0, less than string length of string, I plus plus, right? And make sure that if the string is not empty, in that cases, num string of I. So this is here the num string of I which is equal to the str of I. So string of I is equal to, so here I am going to get the ASCII value for the string. Say for example, if I am entering my any values, so here let's assume that all the values, right, which are in the capital letters, right? So the input, whatever the input which is received in the small letters, which are converted into the capital letters, right? So str of I, right, which will be in the capital letters. Say for example, here, what was the input I received? SCAMPATH. All those characters are in capital letters, right? So, first character letter, say for example, yes, right? Yes ka corresponding ASCII values. What is the corresponding ASCII value for yes? Here, I can just scroll little down.